Exercise 4f, question 15. The first thing I would say here is read through the text a couple of times before getting into this problem. I've done that and I've drawn down a diagram, a fairly standard diagram with regards to how I like to answer these problems. I've chosen a positive direction. For me, I'm dealing with vectors, so V and B are vectors, so the directions that are shown. If they happen to be negative at any point in time, it simply means the object's moving in the opposite direction. And then I've gone ahead and I've just applied the conservation of linear momentum, simplified that down, and as I like to do, when I've got a result which looks reasonable, I'll just put a little box around it. Okay, so the next thing is to use the restitution equation, and I'm going to use my preferred version, which is essentially minus E equals V2 minus V1 over U2 minus U1, and I've used the diagram just to make sure that everything is correct with regards to the signs, and then again I've just rearranged that a little, got it into a reasonable looking state, and I've put a box around it. I've now labelled these up 1 and 2. So the objective here is to actually find what E is equal to in this case. So I'm going to do that by eliminating the variable B, and so I'm going to substitute 2 into 1, which will give me the line, as you can see, that I've divided throughout by V. I'm now going to just rearrange it by making E the subject of the formula, and you'll see that we get E is equal to K plus lambda divided by lambda parenthesis K minus 1 as required, so QED there, that's been proven. Now for the second part, it says that we've got to show that lambda has to be greater than K over K minus 2. I'm not quite sure at this moment in time why it doesn't say greater than or equal to, because I think it can also equal that, but I'll have a further think about that later on. Okay, so this implies we're going to get an inequality. Where could an inequality come from in this case? There are two possibilities. The first one is we know that E itself has to lie between 0 and 1, so perhaps that's going to lead us in the right direction. And we also know, looking at the diagram, that of course B has to be greater than or equal to 0 because of the nature of the collisions that take place. Now, my thought is here that given that it's fairly obvious that B has to be 0, that would probably lead to a trivial solution. So I think that the answer that we want is going to come from the first inequality, that E is between 0 and 1. Now, what I have done is, I think it'll say it now, yeah, there it is, quick think, and I sat down and thought about this and kind of played with my mind how it would work, and I've decided to try using E is less than or equal to 1. Okay, now the working is flowing out underneath there, and so let's just see what I've done. So we know what E equals from our line that says QED on it, and I'm just going to set that expression less than or equal to 1. I have then multiplied across by lambda times by K minus 1. And you've always got to be careful when you're multiplying with variables and inequalities, because of course if it so happens that something is negative, it will affect the inequality sign. However, I've put there by the yellow asterisk, we know that K actually has to be greater than 1 because of course the first sphere or ball, the one that's moving with the velocity kv, catches up with the other one that's moving with the velocity of v, and that can only happen if k is greater than 1, and therefore k minus 1 is going to be a positive value. Okay, so it's always worthwhile having a good old think to make sure that nothing can go wrong. Okay, and then the next part really is just algebraic manipulation. Essentially what I've done is I got the lambdas on the same side. As you can see, I then pulled a factor of lambda out. I then divided throughout by K minus 2, and I ended up with the fact that lambda has to be greater than K over K minus 2. Okay. I'm just going to think, I'll come back to that again in a second, but let's just see what happens on this last step. Now, we know that lambda has to be greater than 0, and we know that because lambda, of course, is just the is lambda times by m is the mass of the second object. So if lambda is greater than 0, that will imply that k over k minus 2 has to be greater than 0. And if you think about it, if k was less than 2, so for example 1.9, the denominator here would actually be negative, in which case that would give us an error. So in fact that would give us that lambda in fact could be a negative value, which is clearly not true. Therefore the reality is k has to be greater than 2. And in fact on the previous step that was kind of quite important, because if you look back I divided throughout by k minus 2, and of course if k minus 2 could have been negative it would have switched the inequality sign, which could have caused a problem on the line above. Anyway, I think everything's taken care of there, apart from the fact I'm not sure why the book says strictly greater than, because I suspect it can be greater than or equal to. In fact I tried it with a few numbers and it did seem to work. Okay.